So our time is here. Most welcome to our afternoon webinar. This webinar is about hazardous area classification via index. My name is Árpád Veress, and my partner for the afternoon session, like for the morning, will be Mr. Mátyás Dalnoki, who is our key expert for hazardous area classification. And we will try to introduce you how we do hazardous area classification, what parameters we consider, and why we do believe hazardous area classification is very much essential for any kind of activity, including inspection, authorities, engineering, design, purchasing, installation, EPC, contracting, whatever. Okay, so what is a hazardous area classification? There's a very simple definition. An explosive atmosphere is present in an area where it is present or can be expected to be present. Okay, that's the very key definition to here. Certainly, hazardous area industries are various, endless. The normal ones, we used to say normal ones, like chemical processing plants, refineries, shipyards, petrol stations. But let us not forget those ones which are kind of trendy today: biogas, hydrogen, LNG, then the printing industries, hospitals, aircrafts, woodworking areas, car industries, wastewater technologies, sugar refineries. So everywhere where possible, gas and dust hazard might be applicable, and you need to count, you need to design accordingly. Okay, that's where the basis is every time, everywhere, the explosion protection definition, which is hazardous area classification. We do have IEC 60050, which give a very interesting definition to the hazardous areas: an area in which explosive atmosphere is present or can be expected in quantities such that special precautions for the construction, installation, and use of equipment are required. What it means: you need to do your design based on the data, technology, okay, what substances we use, how much we use, what pressure we have, what temperatures, ambient, inside, and certainly what function we would like to realize and keep up running for the whole lifetime of the site. And what is also very important, whenever there is modification, this hazardous area classification has to be updated, and there is a change management technology is required, because then it needs to be followed up. Certainly, the outcome of hazardous area classification is all the time an EPL, an equipment protection level, which defines the possible installations to be used, to be applied for. But besides that, it will also create a definition what procedures can be run, how we can work there, what work safety, what procedures can be realized. So it has a strong influence, everything related to explosion protection and all around. Okay, that's a very basic understanding. And once again, if there is any kind of modification, it has to be updated immediately, and then a follow-up activity is needed. So how we do this, how we are doing this, that will be more like the topic of our webinar. We would like to create a kind of discussion environment where Mátyás and myself will discuss this topic. We do have, for the purpose, we created together with an Italian university together, Aragas and Aragas, and the Aragas is more like for the gas hazardous environment, and the Aragas is more like the dust hazardous area. Today, this afternoon session will only focus on Aragas. We will go through a project, how we do hazardous area classification, and Also very important to mention that our software solution strictly complies with all relevant standards and all relevant regulations. The older version and the newer versions as well from the various standards like the -10, like the CEI, the Italian versions, and up to the American or even international standards. Okay, so that's very important to mention that here we can deliver a complete coverage for all hazardous area projects globally. What is also important to mention, and Mátyás will, let me say, introduce it in a detailed way, that the outcome of this Aragas and Aragas software is a Word document with a full set of informations regarding extent, regarding calculations, and regarding a possible safekeeping of the hazardous areas. Okay, so this we would like to introduce it to you, and now I give the word to Mátyás.
Good afternoon, everyone. My name is Mátyás Dalnoki, and let me to switch off my camera because of the weak internet connection. So I would like to share my screen. Today I would like to show how we use the Aragas Plus software in case of hazardous area classification, and what would be the result of the Aragas software, what we can print it out and edit freely and use it for the documentation preparation. Oh, one more thing, sorry. English is not my native language and not the native language most of you. So if anything is not clear, please don't hesitate to ask back immediately. I prepare a little bit complex, but not so difficult painting production facility for you for this presentation. We have got a working hall. Just close your eyes and imagine an old empty hall with artificial ventilation. In this hall you can find some mixers which are very poorly prepared, likely barrels with mixers, with agitators. There are some pumps. There are some tanks for the temporary storage of the product, and these tanks, ventilation pipes located inside and vented inside into the building. These ventilation pipe didn't drive through the wall or through the roof into the atmosphere, into the open environment. So these four tanks ventilated directly into the working hall. We have got a small downloading filling line where the product, the main painting product, has been downloaded and filled the cans. We have got the raw material storage and the product storage area, and this whole has got only one common artificial ventilation. There is no separation walls, no separation rooms in this hall, so everything emitted into this hall, and this hall has got a ventilation, and the inlet air goes from the top to the down. The exhaustion fans can be around the bottom part of the hall. So we have got an up to down ventilation. The ventilation rate can be 2 per hour. That will be the basic situation. And now let's see the software. What can we do with this? At first, we have to prepare a new project. To create a new one, we can give the main project data, what we would like to record it into the software, country code, address, customer, whatever, and the name of the project. The close button is everywhere the enter button here in this software. Later, if you find your project and want to modify it, you can modify, of course. At the second step, we have to define the environment of the emission sources. It could be a little bit strange because if you follow the software method, the standard method at first focus on the emission sources, define the different emission sources, classify them, which kind of graduate it has, which kind of class of it, and what are the hole size and so on. But the software can manage within one project several kind of different emission sources within the same environment. So the software built it up logically to define the environment at first. And if you have got several or different part of the emission sources, the environment data put into automatically from the environment chapter. And this is what we have got now. So the environment name is painting hole. You can attach a picture about if you would like or whatever. Of course, we could have natural ventilation. In this case, we could choose the wind speed volume according to the standards given data, but now I said we have got artificial ventilation. So we choose it's a closed area. In this case, we can choose general artificial ventilation or maybe local artificial ventilation if we have got, or if we haven't got any kind of artificial ventilation, we can choose natural. In case of natural, we can calculate the ventilation. Yes, at first I have to give the numbers of the room. The long side would be 30 meters, the short side would be 20 meters, the height would be 6 meters, and the filling coefficient maybe 10%. Just put some data inside. So if we would like to calculate only with the natural ventilation, we have got several different possibilities to give how many openings we have got, which are the surface, what would be the outside wind speed, what would be the coefficient, and what would be the delta CP, and the software built in a guide, an Italian Standardization Association guide, which could help us to define the delta CP. But now I decided a little bit easier situation because of the limited time. And I said we have got only general artificial. I put the parameters of the building, and we know we have got what would I say? Yeah, 2 times per hour, which means that roughly 6,000 cubic meter per hour, which would means that 2 point something like 7 cubic meter per second. And when I put it here, it's calculate the wind speed in the hole. We can give the habitability, of course. We can give the ventilation efficiency factor as usual, the ambient temperature, and if we have got some residual ventilation, for example, natural ventilation comes from the openings, or local ventilation because we have got some hood somewhere or whatever, we can calculate with this. If we don't like, because we haven't got, and in this case we haven't got, just let it to 0, and that's all. Close for the enter. And we set it the environment. Now we can choose substance. In the software, basically installed more than 300 different materials. You can search it by name or by case number. whatever we would like. There is a possibility to give new material into the database. There is a separated sheet I will show to you. No, I said we should use acetone now, but in liquid form, of course. But we can choose whatever we would like. Of course, there is a painting hall in this project, in this imagination. So in this case, there would be a lot of different kind of materials. When you choose one, we try to focus on the evaporation factor. In case of acetone, we use Gestis database. When we check the material's properties, we can see that the vapor pressure at 30 degrees, which is in the imaging situation, that the process and the ambient temperature also. There is almost 3.8 megapascal, sorry, 380 hectopascal. So now, when we set it the substance, we should say something about the source of releases. And if you think it back, we have got mixers, these kind of open barrel mixers. So at first, we should to examine in the hole the evaporation from this mixer. We have got simple pumps, simple one mechanical sealed pumps. So we have got primary grade of release here. We don't know because we don't see on the drawings, usually, I can say, the pipes. But we must be sure that there are a lot of junctions, pipe threads in this factory. And after that, we have got tanks with vent pipe here, and we have got some open surfaces when we fill the cans. That's all what we have got now. So at first we should start with the mixers. I said somewhere that the surface of the mixer is 1 square meter, because it was say simply.
What is also important to mention that if you have a number of substances, then you need to do the hazard serial classification each individually, okay? And then certainly based on the outcomes, you can make your final hazard serial classification. That's a very important note to hear.
One more important thing, why we need the evaporation pressure of the material, because now here we can say that we have to set how much percentage will evaporate during the evaporation. Fugitive emission we will talk about later. So now we can count the grade of the emission. In this case, we can choose different kind of emission source. Pool evaporation when the size is known, the pool evaporation when there is no direct contact with the air, different kind of containers what we have got. When we don't know the area, the surface, the evaporating surface, we have got some other situation when we dosing, for example, or we have got another kind of pool evaporation, and we have got jet emission. That's what we will use in case of pumps and in case of junctions. So now we have got an open surface now, a barrel which can evaporate, and there is a direct ventilation from up to down. So I choose this. In this case, we should to give the grade of release, because this in this case there is not a continuous process, it's a batch process. So we mix the paintings, we pump it out to the temporary tank, and they don't work continuously, 4 shifts and whatever. So it's a primary grade of release, but I set it now here. We know the evaporating surface, which is 1 square meter. We can set the temperature of the substance, the temperature of the ambient, and there is an interesting point when we could set the safety factor. The 60079-10-1 2015 version has got safety factor. The 2020 version deleted safety factor. We have got 2 software version. The 2.0 is based on the 2015 version of the software. The 3-point version is based on the 2020 version of the standard, but the interface of the software, it remains the same. So the safety factor can be added in both cases, whatever standard version you and software version you use. But please take care that the safety factor is only exists in case of use of the 2015 version of the standard, the 2.0 software version. So now I set it to 1. Because if I set it 1, it won't change anything in the equation. The air velocity came from the environment, the efficiency factor came from the environment, the residual ventilation, I didn't set anything because we don't have, so it still remain empty. Calculate and close. We have got something. In the result, the software said that around the barrel there is a very small amount of hazardous area, which is zone 2 now. Because the dilution is very high, the resolution of the figure is not let to see the concrete numbers, but it is written. And the zone 2, because of the high dilution factor and the fair availability is set in case of this primary source of release zone 2. But we hasn't finished yet. You can check the volume of the background concentration and the comparison between the background concentration and the critical concentration. Now we set it only 1 source of release, and it was a mistake by me, sorry. We can edit it because I forgot that we have got 6 emission sources, and I can set it somewhere.
I wouldn't say it was a mistake. That was with intention, because in that case you can see that you can go back and modify and see
and
immediately the result.
Here.
Okay, because it has influences on the final outcome.
So we have got 6 same kind of mixers. And
that's coming from the description of the technology.
Yeah, and the background concentration has changed. And please try to check how change the background concentration step by step when I set up new source of releases. So next source of release would be the pumps. For example, new, we set pump.
Here we have 6 again.
Depth. Liquid, not 100%, but 0.8 because of the evaporation pressure. Substance source of releases, yes. focus on the pump. Great. This is a jet emission.
It comes from the standard.
It comes from the standard, yes. And this is a primary grade of release. We can choose it from the standard also. Let me say that the relative pressure is 3 bar. It's nothing difficult.
The
discharge coefficient can be set like this, written in the standard. The temperature I will set to 30 degrees. The safety factor remains to 1. The whole cross section. The software let us to choose from the whole cross section given in the standard. Moving parts, pump and compressors. Typical values when the opening will not expanded, 0.25 square millimeters. When you can set up the erosion, it lets you to choose from 1 to 5 square millimeters and so on. But the developers installed into the software the Italian Standardization Association guide, which is given to the 60079-10-1 standard. It's a guide, but you can use if it led to you. But you can find the typical software values given in the standard table, which are built in. So now we choose the 0.25 square millimeter. The main velocity came
Mátyás, there is a question.
Yeah?
Aren't the pumps considered as secondary grade of release?
We can consider as a secondary grade of release. For example, if the pump has got a magnetic gearbox, or there is no direct contact with the material. So, or if could be no release, if you have got a pump which double sealed. If you check the standard EN 1127-1 from 2019, there are some typical examples when an emission source can be enhanced tight, and in these cases there are no emission. So, for example, the double sealed pumps and compressors doesn't count as an emission source, and there are a lot of several examples also. In case of a simple mechanical seal, we could say it can be a primary grade of release if due to the corrosion or due to the normal usage by time, because it was written also in the standard. What I would like to show. Yeah,
Mátyás, just one comment. That's important to say that what you mentioned is an EN type standard, but with the same texting, the same content from the EN 1127 has been added to various standards related to explosion. Okay, so you will find the same texting mentioning the same standard. So that's a global standard. Okay, please consider.
Thank you very much. Thank you for the comment. And now I didn't forget to set the number of releases from 1 to 6.
6, yeah.
And let's see what we got. Now we have got a double zone. We have got a zone 1 and the zone 2. In this case, roughly ½ meter, but the background concentration still rising. It's still lower than the critical concentration, but the dilution of the ventilation decreased from high to medium category. So let's put one other release. The next one would be the junction.
So these are the flanges.
Flanges, sorry. And now we can speak about fugitive emission. In the standard, there are possibility to calculate the fugitive emission, but take care that the direct release from a flange can be calculated only once, because IC scope and within this parallel, the HAC scope is only one independent failure at the time. But at the background, we have got a lot of, we could have a lot of emission sources which have got a very small amount of emission, because these are sealed, but the background concentration can be raised with them. So now just let me say that we have got simple flanges, nothing special. So I choose this kind of flange, piping flange. I said we have got, let me say 50, not so much, not so less. For something it will be good.
And let us be honest, this is typically goes forgotten that there are pipes and there are junctions and there are aging gaskets in between. So this is also an emission source which needs to be considered.
Yeah, but one time we have to calculate the emission source from a flange. So now we would say we have got a secondary grade of release with 3 bar pressure, with 1 safety factor. The temperature is also 30-30. The whole cross section. It's now we are in a fixed type, ring type joint connection. This is 0.1 square millimeter from the standard. So now we set the whole cross section. The ventilation efficiency is the 3 as before. Calculation, what we got. We have got a small amount of negligible extent of hazardous area around the flange, but the background concentration is still rising. We have got 2 more source of release, the storage tanks ventilation pipe and the open cans during the downloading. So follow it with the tanks, the storage tanks.
Certainly, here need to be very consequent with the data, okay, provided to the system, because we are talking about the same area and the same unit.
Yes. Great. Now we should choose the container situation. This is also a primary grade of release. The substance is 30. There is not the best drawing, but you can imagine how would it be. The S means the surface of the evaporation, the liquid surface. Let me say 2 square meter or whatever. The B is the end of the pipe. It's 0.2. The whole height of the tank, let me say 2 meters. Sorry, minimum height. Sorry, no, this is 0.3 and this is 2 meters. Yes. Environmental data. what we need to set. How many tanks we have? Yes, 4. Very small amount of hazardous area around the tank pipe. That's what we have got now. And we will have one more. Emission sources, which could be the same situation as before. Sorry, no, I missed it. I forgot to add the emission source new. Yes. Can filling.
You need to follow the whole procedure. That's very important.
Release. Set the filling product. Grade. It's also an evaporation. Let's say new one. It also can be a primary because it doesn't take too much time to fill a can. Of course, if you think about the continuous process, it could say it can be continuous because in every time there is a can where is filling and evaporating, but they doesn't work for a whole day per 7 per 7 per 365 per 365. So I would say only primary grade of release would be 0.3 inches of square meter or 0.2. It's enough. The number of the release, if you think it over, of course it would depend on the process, but we would say it's a manual process. There is 8 on the row, and after the filling, the manual closing process has started. So at the time, I would say there is 8 can which can be evaporated. These numbers came from the same. I don't forget to set the safety factor to 1 and calculate. Close. So now we almost finished because we set it all the different kind of emission sources. We can check the background concentration is still less than the critical concentration. So these zones, what's set it and got at the end, are ready to draw as a bubbles around the emission sources. What we can do now to show our calculation as a result, we can print it out in an editable form. Here, we could say for Apex. This software is able to manage the ignition source analysis as a risk analysis. Honestly to say, we don't use in usual life in everyday process this part of the software. We use this software for hazardous area classification process only, but it contains a risk analysis method with an ignition source analysis method also, and you will see at the end when it would ready with this printout preparation process, that it contains the risk analysis results also, which are not set in this presentation, but it can be, and it can be visible at the end.
It's very important to say that based on the hazardous area classification, a risk assessment needs to be done. And certainly the software includes this functionality as well. How you do it, it's up to you, but it needs to be done. And the result of it will be, let me say, your overall operation. And that's a very important topic. And as you might have seen, all these data refers to the user requirement specification. So we need to have the full intel to go forward.
So at the end, we have got a Word document which contains the standards, the basic standards, what it can be used during the calculation and during the hazardous area classification. There are the main definitions is also written, zones definitions, and the basic data of the calculations. Environmental data, if we would have natural ventilation, openings or whatever, it should be shown here. With the quotation also. But in our case, there is only artificial ventilation. In the next, there is a list about the hazardous materials. During the process, you can choose in the same project different materials in case of different emission sources. So just let me to say that in this presentation, I can use, for example, acetone for the mixers, toluene for the pumps, or added a new emission source like mixers with toluene and so on. And at the end in the report, there are the main standardization properties, standardized properties in the standardized form. This is the ignition source analysis part, which is not set yet by me because it was not in the scope for today. But if we would set the results would be here, the general data, and now there will be listed the all calculations, what we would do and what we have done now. So with the quotations given from the standard, with the results, and the summarization Excels with the results, of course, and with the figures what we have got at the end, like this. And at the end we have got the dilution situation, dilution time, dilution factor, different coefficients, the type of the zone, the possibility of the reduction of the zone if you would like, but now in the software there is not an automatically built-in thing because it's only from the guide of the Italian guide which can be used, but there is a possibility to reduce your zone if you use this guide at the end. It's written here. If you don't need, you can delete it. And a summarization. What was the emission source? What would be the result? And the requirements, the minimum requirements for the equipment into the hazardous area. If you do a risk analysis, the summarization of the risk analysis can be here shown also. Our second emission source, which was the pump, with the same methodology, equations, summarization of the results, figures, dilution calculations, additional probabilities for the reduction and the summarization, and so on, so on, so on, for the whole process.
Why is this important? Because for most of the cases, let me say, we receive hazardous area classifications by a drawing. Okay, so we receive the drawing, and from the drawing itself, you cannot be sure, you cannot say that you are on the safe side, that you have a full understanding how the hazardous area classification has been done. So this software, let me say, would give an immediate summary and overview about the whole process, how you did according to the standard, according to your relevant standard, and complete definition of it. Okay, certainly this is a documentation which you might edit. Okay, make it to more your let me say company profile. But that was our intention. Okay, and that's a very important topic, and certainly you might add a few additional things, etc., but you can change it. Mátyás, there was a question whether with the software, how we can handle hybrid mixtures.
Yeah, it's a tricky thing, and that's what the last thing what I would like to show you for today. There is a tool when you can screen when you can add more materials, more substances to the database what you are using, and here you can add new, for example, and if you have got any physical properties data about your hybrid mixture, you can add it to here.
So that's a very unique feature that you can come up with mixtures, but you need to have a very precise database, okay, of it, which is let me say very crucial point of it.
In our practice, there was no any case when the customer has got data about the mixture, what we should to analyze for the hazardous area classification. And in the most cases, there was no possibility to send it to a lab to measure it. So in case of mixtures, we have to repeat the calculations. At first, we choose the most evaporatable component for the mixtures. And the second, when we repeat the calculations, we choose by other point of view the lowest explosive concentration limit. That's the two main point, and we check the results, and we choose the which gives us a higher volume for hazardous distance. That's what we usually choose for the mixtures. That's all. If you don't have data, you have to choose and filter somehow.
But I mean, if we know the properties, okay, then we can do the calculation, and the software itself might do the calculation for the temperature classification and the gas group immediately. Okay, depending on the mixture. But you have to have a very precise data, which is, let us be honest, most of the time is not an available data, like Mátyás said. So that's let me say shall be a very obvious topic. And on the other side, for the dust, is just our experience. The different dusts behave completely differently in different technologies. Okay, So even if you have like a printed database, some data for the said dust in the technology, it might behave differently. So in that case, you know, it's just additional information. We operate here in our office a dust lab. We used to do dust lab testing back in Europe. And it's really interesting to see the differences, to be honest. So that's sometimes relates to very interesting results in general. So that's more like the topic. And if we talked about Aragas, yeah, here is a short overview. We are planning to have a same session with Aragas as well in a few weeks' time. If you are interested, we invite you again. We hope to welcome you again. And that's also a very unique feature, very unique software where we can deal with dust hazard and dust technologies, even to say they are completely different from gases in terms of behavior. Here in the follow-up, we summarized a few questions and answers from our side. What can be done with Aragas and how it works. Important to say that Aragas is a PC-based software, so it's not a cloud-based software, not running via internet. We don't store your data. It's running on your PC in your protected environment. And there is a purchasing fee, which we will update you of after the session in email chain. Let me say an email to you. We will send it to you. And there's an annual fee for updates, which we do kind of continuously, depending on the standardization updates, good engineering practice, etc. Certainly, let me say, this software is pretty much applicable for engineering companies, but for end users, for EPC companies, for inspectors, for authorities to check, to recheck various future and existing hazardous area classifications as well. As you might have experienced, to use a software like this, you need to have some kind of understanding about explosion protection, about the different definitions given by the standard. So we highly recommend to proceed with like an ICX COPC Unit 2 module, which is about the hazardous area classification in general, and would give you the credit, okay, to use it properly in a way. On the other side, let me say, Aragas is able to reproduce existing hazardous area classifications, but again, hazardous area classification is not just a drawing, okay? It is a complete set of documentations, including technology, substances, pressures, various values, and the technology itself, okay? What we do with that substance. If there's any limitation, yes, Aragas is limited to one computer, one PC, okay? Certainly it can be reinstalled, which is a kind of easy process, but then on the previous one, it doesn't work, okay? So that's more like an important topic. The presentation itself you will receive as well. Aragas, as a software tool, doesn't create the classification drawings, okay? So depending what type of drawing you use, AutoCAD, ECAD, whatever, or per hand, you need to do it on your own, which I do believe gives you a certain flexibility if you do like that. On the other side, this Aragas can be used for various purposes. even to conduct a gap assessment at the feed stage, or go for a HAZOP, okay? Or like Mátyás said, very detailed, it can be used for a risk assessment, ignition source assessment, or even under the ATEX environment, under the ATEX regulation, even an EPD can be created with it. And to be honest, EPD is a very useful thing because it gives you a description how to handle explosive areas for long term. And last but not least, doing hazard area classification with Aragas, you always need to consider the topic aging, okay? Because as the your technology is getting older and older, certainly the parameters might change as well. Indoor, outdoor, natural, artificial ventilation, these are all possible topics here, as well with hybrid mixtures, okay? So that's a very important topic. CFD, yes, can be used, can be applied, and it can be also used and utilized for offshore installation or even shipyards, ships as well, because under all these IEC standards, we are referring back to the 60079-10 and similar. What type of facilities? I would say each and every, because there is no limitations, and here we can proceed with let me say container solution, plant solution, and some others as well. And certainly NFPA, EI or API, that these are all applicable standards which we use for various projects, with Aragas including. Okay, so that's also a possibility. Just a few questions have been raised. You will receive a certificate of attendance, but just to make it more valuable for you, we prepared a small assessment tool. We developed an online VOC verification of competence tool, which we normally use for different purposes globally with partners of ours. You will receive an access link right after this afternoon session. The same goes for our morning session attendees. And you will have an access like 1 week, but after you start, you will only have like a 1 hour time range to answer 10 questions. These are not horrible questions. These are easygoing questions, but it's, let me say, will show us more your understanding and so on. We just created a WhatsApp group. We will send you the link right afterwards. My colleague Mehmet will do that, and you can join. And we agreed with our morning attendees that we will do follow-ups and we will do more like coming up with some kind of guidance how to do hazard area classification in long term. As you can see, the hazard area classification is a very, very basic approach of EX compliance engineering. That's a must-have, and that's, to be honest, a mandatory act because we want to have our workers safe coming back from site, even ourselves, my colleagues, and all our mates out there. And that means we need to know, we need to be aware of what we are facing, okay? And hazard area classification will give us the definition and will give us this intel information. What is also important to say that this package of information and this complete information set you will receive in a mail in about a few days to your email account. Please check your spam folders. We hope to land it safely in your mail account, just to give you the full access and the full information about the possible opportunities with Aragas. All the morning session and even the afternoon session will have been recorded, and will be added to our homepage. You will receive the link as well, in order to give you the later opportunity to watch again. So really, we appreciate your time and being here. We hope you enjoyed it. We try to make it more live and to make it more work as we usually do it. There are various options, and detailed understanding is really needed to make it properly working for you. Okay, so we really appreciate your time being here, and hope to see you there. See you soon, and cheers, and enjoy the rest of the day. Yep, thank you.